Good morning, my dear students. Last video we had started with the lesson of dimensional analysis. The first video contained the meaning of dimensions and the different dimensional formula of various physical quantities. That is what we had discussed. This video contains the most important part of the chapter. It is the use of dimensional analysis. What are the uses of dimensional analysis? Mostly the numericals that are based on these uses. Like first, to check the correctness of the equation. Most of the numericals are to find out the correctness of the equation. Second use, to find out the relationship between the various physical quantities. And third one, numericals are based on the principle of homogeneous equations. So we shall start with dimensional analysis, second part. We continue with the dimensional analysis. So today we will discuss the uses of dimensional analysis. Why do we study dimensional analysis? So there are three uses of dimensional analysis. First, to convert units of one system into other system. From SI system to CTS system or SS system to FPS system, any other system, we can convert the unit. Second one, to check the correctness of the equation. To find out that the given equation is correct or not, we can use dimensional analysis method. Third, to establish the relationship between various physical quantities. So we have got various physical quantities. We have to find out the formula and the equation or the relationship between the different physical quantities. For this, we are using dimensional analysis. The first use, to convert units of one system into another unit of other system. We know that the magnitude, the numerical value and unit of a physical quantity are expressing the physical quantity. So we have the product of the numerical value and the unit in one system is equal to the product of the magnitude and the numerical value in another system. Or rather we can say that the product of the numerical value and the unit is constant. N1 U1 equal to N2 U2. A very simple example for this is 1 kilogram is equal to 1000 grams. 1 is numerical value, kilogram is unit. 1000 is numerical value, gram is unit. So 1 kilogram is equal to 1000 gram. Okay, so N1 U1 equal to N2 U2. We can make use of this to convert the unit from one system to another system. We have physical quantities P equal to N1 U1 equal to N2 U2. Let us take the dimensions of the unit. M1A, L1 is to power B, T1 is to power C. So N1 into this dimension. Then in the second term, second system, U2 will be another unit. So its dimensions are L2, M2 raised to power A, L2 raised to power B, T2 raised to power C. Now these N product and the unit are equal to P. So we equate both of them. N1, M1 raised to power A, L1 raised to power B, T1 raised to power C equal to N2, M2 raised to power A, L2 raised to power B, T2 raised to power C. And we find out the value of N2, the magnitude. Okay, so N2 equal to N1, M1 upon M2 raised to power A, L1 upon L2 raised to power B, T1 upon T2 raised to power C. Using this formula, we can convert the numerical value of a physical quantity from one system to another system. So this is the way we can convert a physical quantity from one system to another system. I will explain this with another example. I will convert newtons into dyne. Okay, I will convert 1 newton into dyne. Let us take an example of the conversion of unit of force from SI system to CTS system. So we know that the SI unit of force is Newton. We will convert 1 Newton into dynes. had talked about the physical quantity expressed as a product of the numerical value and the unit, which is constant. So N1 U1 equal to N2 U2. The force, SI unit of force is Newton. SI unit of force is Newton, and its dimension is MLT minus 2. Dimension is MLT minus 2. By the formula, 1 Newton is equal to 1 kilogram meter per second square. So kilogram mass meter per second square. Now we have taken M1, L1, T1. M1 represents kilogram, L1 represents meter, T1 represents second. M2 in second CGS system, M2 represents gram, L2 represents centimeter, and T2 represents second. So we have, in this formula we put the numerical value as well as the dimensions. N1, M1, L1, T raised to 1, T1 raised to 1 minus 2 equal to N2, M2, L2, T raised to power minus 2. Now N2 equal to N1, M1 upon M2, L1 upon L2, and T1 upon T2 raised to power minus 2. Now we substitute the values of M1. What is M1? Kilogram. M1 की जगह क्या रख दिया? किलोग्राम. और M2 की जगह रख दिया ग्राम. L1 की जगह रख दिया मीटर. L2 की जगह रख दिया सेंटीमीटर. और T1 की जगह सेकंड और T2 की जगह सेकंड. तो सेकंड से सेकंड कैंसिल हो गए. Now 1 kilogram is equal to 10 raised to power 3 grams upon gram. 1 meter equal to 10 raised to power 2 centimeter upon centimeter. यहाँ ग्राम से ग्राम यूनिट कैंसिल हो गई. यहाँ पर डायमेंशंस क्या हो गए, या वैल्यू N2 की वैल्यू क्या हो गई, 10 raised to power 5. So N2 is equal to 10 raised to power 5, and unit is in CGS system is time. So we have found out the numerical value of the Newton in CGS system, that is 10 raised to power 5 time. I hope it's clear. The second use of dimension analysis is to check the correctness of an equation. From the principle of homogeneity, the dimensional analysis enables us to check the correctness of a physical equation. For this, we examine the dimensions on both the sides of the equal to sign, that is on the left hand side and the right hand side. If the dimensions on both the sides are equal, then the equation is correct. If the dimension of LHS is equal to dimension of RHS, then the equation is correct. So we will take an example to see that whether the given equation is correct or incorrect. Let us take a relationship: kinetic energy is equal to potential energy. The kinetic energy of an object is given by the formula half mv square, and potential energy is given by mgh. So we will check the correctness of the equation. Now, as you know, the pure values, these ratios do not have any dimensions. So dimension of m is, mass is m, and v square is LT minus 1 whole square. This is for half mv square, which is equal to m L2 t raised to power minus 2. This is the dimension of half mv square. Okay. Then we have mgh. Mass m, g LT minus 1, and h is again L. So we combine them together. First m only 1, then 1 L here, 1 L here, L raised to power 1, L raised to power 1, this is L raised to power 2, and t raised to power LT minus 2. This is LT minus 2, so this is LT minus 2. This is acceleration. Acceleration की क्या होती है? LT minus 2. So m L square t minus 2. Now what do we see? The dimension of half mv square is m L square t minus 2. Dimension of mgh is m L square t minus 2. So this equation is absolutely correct because both the sides have got the same dimension ml square t minus 2. I will take another example in which h is equal to ut plus half a to the square. This is the equation of motion. H is equal to ut plus half a t square. Now here this expression, this is LHS and all this is RHS. But in between these two there is a plus sign. equation, we are checking out the correctness of the equation. The values of ut, dimension of ut should be equal to h separately, and dimension of at square should be equal to h. Okay, when the variables are in an expression, when the variables are separated by plus and minus, then each variables or combination of variables should be equal to left hand side. Means ut plus half at square. So in between there is plus. So these are two separate parts. Same quantities can be only added, or same quantities can be subtracted, and same quantities can be compared. This is the fundamental. Okay, only same quantities, kilogram can be added to kilogram only. Kilogram cannot be added to liters. So mass can be added to mass, mass can be subtracted from mass. So whenever there is a plus or minus in between, then all the variables are compared separately. So ut will be compared to h and at square will be compared to h. So dimension of ut should be equal to dimension of h. Dimension of at square should be equal to dimension of h. Okay, separately. And if it is so, then the equation is correct. So first of all, we will find out the dimension of LHS. LHS में क्या है h. h की dimension क्या होगी l. Then we have our dimension of RHS. RHS में पहला term क्या है ut. u क्या था initial velocity. So velocity का dimension क्या होता है lt minus 1 and t is the multiplication. So इसका क्या होता है t. तो t और t minus 1 इन दोनों का प्रोडक्ट क्या हुआ l. So what do we find? This here ut की डायमेंशन निकल के क्या आई l और h की क्या थी l. तो ये वाला टर्म दोनों बराबर हो गए. Next we see half at square. Now half at square. Half has got no dimension, it's a pure ratio. Then a is acceleration. Acceleration की डायमेंशन क्या होती है lt minus 2. Acceleration is meter per second square. So lt minus 2 and t square. Time की क्या है t square. So minus 2 plus 2 cancels out, again l. So what do we see? We see that dimension of h is l, ut is again l, and half at square is l. So this equation is correct. The third use of physical dimensional analysis is to establish the relationship among the various physical quantities. That is to find out the formula for any given relation. So if we know the factors on which a given physical quantity is dependent, then using the dimensional analysis method, we can find out the relationship between these factors. Okay, so the quantities are dependent on another variables. If we know this dependence, we can find out the relationship, or we can find out the formula for that value. Okay, for that physical quantity. Like for example, we know that the time period of a simple pendulum depends upon mass of the bob, length of the pendulum, and acceleration due to gravity. So these are three factors on which the time period of a simple pendulum depends. That is mass, length, and time. So we will find out the relationship between the time period of a simple pendulum, length, and mass, length, and time. So we will derive it out. We will find out the time period of a simple pendulum. Time period of a simple pendulum depends upon the mass of the bob, length of the pendulum, and acceleration due to gravity. So t is directly proportional to m, length, and gravity. We take their path. T is directly proportional m raised to power a, l raised to power b, g raised to power c. So we have to take these values, m raised to power a, l raised to power b, g raised to power c. Instead of proportionality sign, we put a proportionality constant k, and then we write the dimensions of each value on both left hand side and right hand side. So dimension of time is t, mass m, m raised to power a, length l, l raised to power b, and acceleration due to gravity is lt minus 2 raised to power c. तो हमने क्या किया, दोनों साइड की डायमेंशंस लिख ली. टाइम की डायमेंशन क्या है t, मास की क्या है m, m raised to power a, एल की लेंथ की डायमेंशन क्या है एल रेज टू पावर बी और ग्रेविटी की डायमेंशन क्या है T-2 रेज टू पावर सी। उसके बाद हमने जो पावर से एल के वो एक साथ लिख दिए एम रेज टू पावर ए एल रेज टू पावर बी प्लस सी एंड टी रेज टू पावर माइनस 2c। कंपेयर द डायमेंशंस ऑफ ऑन बोथ द साइड्स। यहाँ पर टी था इसलिए हमने एम का कोई वेरिएबल नहीं था तो एम के वेरिएबल एम रेज टू पावर 0 एंड एल रेज टू पावर 0 एंड टी रेज टू पावर 1। यहाँ पर एम नहीं था तो एम रेज टू पावर 0 क्या है 1, तो एम रेज टू पावर 0 एल रेज टू पावर 0 टी रेज टू पावर 1, जिससे कि हम कंपैरिजन कर सकें। तो एन की पावर दोनों साइड कंपेयर करी क्या आया ए इक्वल टू 0, तो एल की पावर कंपेयर करी दोनों साइड तो बी प्लस सी इक्वल टू 0 और टी रेज टू पावर माइनस 2c इसको कंपेयर किया तो एलएचएस में क्या है 1, सो माइनस 2c इक्वल टू 1। इन तीनों को सॉल्व किया, तीनों इक्वेशंस को सॉल्व किया, वी गेट a इक्वल टू 0, b इक्वल टू 1/2 एंड c इक्वल टू माइनस 1/2। क्या आया तीनों इक्वेशन a इक्वल टू 0, b प्लस c इक्वल टू 0, माइनस 2c इक्वल टू 0, वी सॉल्व ऑल दीज थ्री, वी गेट a इक्वल टू 0, b equal to 1/2 and c equal to minus 1/2. So what are we getting? We are getting the powers of the different variables that are used in the formula to find out the relationship between the time period, mass, length and gravity. So we substitute the values of a, b and c in this equation. M raised to power 0, L raised to power 1/2, G raised to power minus 1/2. M raised to power 0 is 1. So T is equal to K under root L over G. So this is the formula of time period. Time period is equal to constant and into square root of length upon acceleration due to gravity. So simple pendulum of a simple pendulum, time period of a simple pendulum. The last thing of the lesson is the limitations of dimensional analysis. So what are the limitations of dimensional analysis? The first limitation, the value of any dimensionless quantity cannot be dimensionless constant or quantity cannot be calculated from this formula. Okay, so constant, dimensionless constant cannot be calculated. Like for example, the last thing that we discussed was time period of a simple pendulum. T is equal to 2 pi under root L over G. This is a formula, actual formula, but we cannot get the value of 2 pi. So we can only get a relationship between length and gravity, but we cannot get the value of constant 2 pi. Now if the quantity depends upon more than 3 factors, then relationship among them cannot be established, because we can have only 3 equations by equalizing the power of m, l and t only. So we have taken only 3 variables, mass, length and time. So we can get only 3 equations, and if the value depends upon more than 3 factors, then it cannot be calculated, because from mass, length and time we can get only 3 equations. Okay, and if the value is dependent upon 4, then we cannot get the formula for this quantity. Then trigonometric ratios, the equations that contains trigonometric ratios, sin theta, cos theta, tan theta, exponential, logarithmic values, terms cannot be analyzed by it. Okay, dimensional method cannot be used to find out the trigonometric formulas that contain trigonometric values, logarithmic values or exponential values. Last thing, dimensional formula may not represent a unique physical quantity. Hence, physical quantities of different nature may provide dimensionally homogeneous equation. Example, if there are more than one physical quantity that have got same unit, then their dimensions will also be same. Like for example, force is Newton, distance is meter, unit of work is Newton into meter, that is equal to joule, and we have the unit of torque also Newton into meter. So both work and torque will have the same dimensions because they have got the same unit. Is it clear? So two different physical quantities can also have the same dimensional formula. So we have finished up with the lesson. I hope if you watch the video more than once, you will be able to understand the chapter, please try to do the numericals. Okay, because certainly you will get one numerical on this dimension in the board's paper.